This time we have our discussion about auxiliary equation with repeated roots. So this is in continuation with our discussion about auxiliary equation with distinct roots. Now take note, in our distinct roots, in an auxiliary equation with distinct roots. Okay. So we have our m sub 1, we have our value of m sub 1, our m sub 2, we also have the value of m sub 2, and then let's say m sub 3, we have also the value of m sub 3 in a distinct roots. In repeated roots, so this is now repeated roots, we have our m sub 1, for this case, that is equivalent to m sub 2, which is also equivalent to m sub 3 or m sub 4. In other words, the value of your m here are equal. For distinct roots, they are not equal. Now, so if we have in a repeated roots, so say for example, if we have here our c sub 1, let's say e raised to bx plus c sub 2 e raised to bx plus c sub 3 e raised to bx, then when we solve its y, that is equivalent to c sub 1 plus c sub 2x plus c sub 3 x squared e raised to bx. So if you have noticed here, in our constant, we have here x, x sub 2, x sub 3, and so on. This is for repeated roots. Now, we will try to have our example 1. Okay. Solve the equation. So, our equation now is, let's say, d to the fourth, or the fourth derivative of y with respect to x, minus 7d cubed plus 18 d squared. Okay, this is d squared, and then minus 20d plus 8 times y is equivalent to 0. Okay, so this is our equation. When we solve this equation, of course, we need to write its auxiliary equation. So instead of writing d, we have your m to the fourth minus 7m squared. So this is 7m squared plus 18m squared. I mean 18m squared. This one is cube. Let me erase this one first. So we will write here cube. So 18m squared minus 20m plus 8 is equivalent to 0. Okay, so when we solve this auxiliary equation, we make use of synthetic division. So in synthetic division, we have here 1, negative 7, and then this is 18, this is negative 20, and then this one is 8. And then we have to write here our line. Take note, 8 has a factor of 4 and 2. And also 8 times 1. Positive, negative. Positive, negative 4 and positive, negative 2. Positive 8, negative 8. And positive, negative of 1. These are factors of 8. So we will we will choose one of its factor to write here. So I will be choosing the smallest number, that is 1. So 1, bring down 1. 1 times 1, that is 1. When we add this 1, that is negative 6. Negative 6 times 1, that is negative 6. 18 plus, we always have here plus. 18 plus negative 6, that is 12. 12 times 1, that is 12. And then negative 20 plus 12, that is negative 8. Negative 8 times 1, that is negative 8. And then if we add this 1, that is equivalent to 0. Therefore, one of our factor m, let's say m sub 1, that is equivalent to 1 because we arrive here into 0. So If this is m to the fourth, then this one is m cubed. So I will write here as m cubed minus 6m squared plus 12m minus 8. That is equivalent to 0. Okay, now in synthetic division, we will now write this one. Okay, so we have another synthetic division. Okay, so I will transfer this one first. Okay, so we will make use of synthetic division for this m cube. So we have here cube, 1, negative 6, and then 12 plus 12, and then negative 8. So that we have here again negative 8. So for negative 8, we have our factor 1, 2, 4, 8. So we will make use of 2. So we have here 2. 1, bring down 1. Again, this is positive. 1 times 2, that is 2. Negative 6 plus 2, that is negative 4. Negative 4 times 2, that is negative 8. 12 plus negative 8, that is positive 4. 4 times 2, that is positive 8. And then if we add this one, that is 0. So again, we have here 0. Therefore, one of our value of m is equivalent to 2. We will make this one as our m sub 2, which is equivalent to 2. Now this one is now, if this is m cubed, this time this one is m squared. So m squared minus 4m plus 4 equals 0 for this part. Now m squared minus 4m plus 4 equals 0. We can factor this one directly. So that is m plus 2, m minus 2, m minus 2. So we have here m minus 2 times m minus 2. So that negative 2 times negative 2, that is positive 4. Negative 2 plus negative 2 equals negative 4. So that is equivalent to 0. This will be our factor. If you excuse, if you do not know how to factor this one, then you can make use of your calculator. So for this case, our m sub 3 equals 2, and then our m sub 4 equals 2. We have two values of m. M equals positive 2, m equals positive 2, because we will transfer this one to the other side. So that becomes positive 2. Okay? So we have our m sub 1. We have here our m sub 1. We have here our m sub 2. We have our m sub 3. And then we have our m sub 4. If you have noticed here, m sub 2, 3, and 4 are equal. We call this one as repeated. So, repeated roots. So, when we solve this one, our solution now equals, our m sub 1 equals 1. So, this is distinct. So, kapag distinct, we have here c sub 1 e raised to our equation m sub 1, that is 1 times x. Okay? Plus, this m2, 3, and 4 are repeated, so we will make use of c sub 1, c sub 2. We already have our c sub 1, so c sub 2 plus c sub 3x plus c sub 4x squared times e raised to 2x. This will be our final answer. Another example for repeated roots, we have solved the equation, the fourth derivative of y with respect to x plus 2 times the third derivative of y with respect to x plus the second derivative of y with respect to x equals 0. Again, we will write its auxiliary equation, that is m to the fourth plus 2m cubed, this one, plus m squared is equal to 0. Take note, this is m to the fourth, then we have to expect that we have 4 values of m. Now, if you have noticed, this can be factored by m squared, our common. Let's say m squared times, this one is m squared plus 2, m squared plus 2m plus 1. That is equivalent to 0. Okay? So, if you have noticed here, m squared times m squared plus 2m plus 1, this m squared equate this one to 0. Therefore, we have to value square root of 0, that is 1. I mean 0. So, in other words, we have our m sub 1 is equal to 0 and then m sub 2 is equal to 0 for this case. However, on this side, we can factor this one by factoring, that is m 1, okay, m plus 1 times m plus 1 equals 0. So this is the factor of m squared plus 2m plus 1. You have your 1 times 1 equals 1, 1 plus 1 equals 2m. Okay? So, in other words, if this is the case, then this value m plus 1 is equal to 0. This one is m plus 1 is equal to 0. So that here, transfer 1 to the other side, that becomes m equals negative 1. As well as this one, m equals negative 1. So this will be our m sub 3, this will be our m sub 4. So for this case, our m sub 1, m sub 2, this is repeating, and then m sub 3, m sub 4 is also repeating roots. So our value now, y, that is equivalent to m sub 1, 0, 0. So c sub 1 plus c sub 2x times e raised to 0x. So this is for repeating. And then the other one plus c sub 3 plus c sub 4x times e raised to negative x. This is negative 1. Therefore, our final value for here, this is e to the 0 equals 1. Therefore, our final value y is equal to c sub 1 plus c sub 2x plus c sub 3, c sub 3 plus c sub 4x multiplied by e raised to negative x. This will be our final value. Okay. Now this time, we will proceed to, if this is auxiliary equation, take note for auxiliary equation with repeated roots, we have here c sub 1, c sub 2, x, c sub 3, x squared. So you have here c sub 3 plus c sub 4, x. Because this is repeated, this is also repeated roots. Okay. Now, once we have our distinct roots and then repeated roots, this time we will proceed to imaginary roots. Okay. So an auxiliary equation with imaginary roots. So our roots here is imaginary. So let's say our m is equivalent to a plus b I or ib. This is imaginary. So when we have our imaginary roots, the solution here for y, take note, our solution for y, that is equivalent to, let's say, c sub 1 or c, and then e raised to a x, okay? This is a x, and then cosine of bx. Our b here is the equivalent value of b here. Okay, so e raised to ax, our a, and then our b. Okay, plus another constant, let's say c sub 2. We call this one as c sub 1. And then this time, you have here e again, e raised to ax. And then, instead of cosine, we will make use of sine bx. This is how we compute our imaginary roots. I mean auxiliary equation with imaginary roots. Okay, we have our example. Let's say example number 1. We have d cube minus 3d squared plus 9d plus 13. Now take note, you can make use of your calculator to solve your roots. Okay, so we will make use, when we solve this one, again, we will write its auxiliary equation, that is m cubed minus 3m squared plus 9m plus 13, which is equivalent to 0. Okay, now we will write our solution. We have here 1 using synthetic division. You have here 1, negative 3, and then 9, and then 13. Okay, so 13. So what are the factor of 13? Of course, 1 times 13. Okay, so we will make use of 1. Bring down 1, we will make use here as positive. 1 times 1, that is 1. Negative 2, when we add, negative 2 times 1, that is negative 2. Negative 2 times 9 plus negative 2, that is 7. 7 times 1, that is 7. Again, it will not equal to 0. So make sure this will not be equal to, make sure that this is equal to 0. So this time, since it will not equal to 0, so we will change here our roots. Okay, so allow me to erase first this one, and then we have here. Okay, so instead of writing 1, negative 1, we will make use of negative 1. Okay, bring down 1. 1 times negative 1 equals negative 1. When we add this one, that is negative 4. Negative 4 times 1, that is positive 4. And then we add this one, that is 13. 13 times negative 1, that is negative 13. And then it equates to 0. Thus, our m here is equivalent to negative 1. Let's say this is m sub 1. So this is now m squared quadratic, no? M squared minus 4m plus 13 is equal to 0. If we make use of synthetic division, we cannot solve here. So instead, we will make use of, if you try this one, try to solve this one, this equation using synthetic, well, we have to make use of quadratic equation. Okay, so take note of our quadratic equation, that is m equals negative b plus minus the square root of b squared minus 4ac all over 2a. So we will make use of this one. Okay, so we have here m is equivalent to our negative b, so negative times negative, positive 4, plus minus the square root of our b squared, we have here negative 4 square, minus 4 times a, we have here 1, times c, that is 13, all over 2 times a, that is 2. Okay, we will divide 4 divided by 2, that is 2, plus minus, and then square root of 4 times 4, that is 16, 4 times 13, 4 times 3, 12, carry 1, 52, minus 52. Okay, 4 times 10, 40, 3 times 4, 12, 52. So this is equivalent to 2 plus minus 16 minus 52 That is 16 minus 52. We have 52, 12, 40, 38. Okay, 38. Let me try. 52 minus 16. So we have here 12 and then 36. Okay, 36. So we have the square root of 36 negative. The square root of 36 equals 6. So that is equivalent to 2 plus minus square root of 36 equals 6i. Okay, 6i. Okay. By the way, we cannot do this one. Wait for a while. Supposed to be, we have here our over 2 over 2. So divided by 2, that is equivalent to 3. Okay, 3i. Okay, 2 plus 3i. That will be our m, value of m, 2 plus 3i. So we have here 2 plus 3i. This is imaginary value of m. Our first m, we have here negative 1. And then the second and third, that is 2 plus and minus 3i. Okay. So that when we solve our value of y, for this case, we will write our value of y. Take note, our m1 is negative 1. So this is distinct. This is distinct. So if that is negative 1, then we have here c sub 1 e negative 1x. So that is negative x. That is for m sub 1. Now how about our m with imaginary roots? 2 plus minus 3i. So our solution for this one, we have plus sorry, plus c sub 2 e raised to, our a here is 2, our a is 2, so e raised to 2x. Okay, e raised to 2x cosine of our b here is 3, so cosine of 3x. Okay, plus c sub 3 and then e raised to 2x sine 3x. This will be our final answer. Another example, we have number 2. Okay, we will just fast track our solution for example 2. We have d raised to 4 plus 8d squared plus 16 times y is equal to 0. So when we write here our auxiliary equation, we have m to the 4th plus 8m squared plus 16. Notice this one, we can factor this one as m plus 4, m plus 4. So we have here m plus 4, m squared plus 4 squared. Okay, m squared plus 4 square. So this is the factor of this equation, auxiliary equation. M squared, 4 times 4, 16. 4 times 2, that is 8m squared. Okay, so that is equivalent to 0. And then, of course, square, we have square root. That means m squared plus 4 times m squared plus 4. That is equivalent to 0. Okay. And then, of course, if this is m squared plus 4, m squared plus 4, then when we have m squared plus 4 equals 0, and then this one, m squared plus 4 equals 0. This one, m squared plus 4, we have here, and then this one, m squared plus 4, we have here. And then, of course, square root of 2, m equals square root of negative 4, which is equivalent to square root of negative 4, that is positive negative 2i. Same with this one, square root of 4. So we have here positive and negative 2i, our value of m for this one, because they are the same. Okay, so if you have noticed, this is a combination of imaginary roots and then repeated roots. Okay, imaginary roots and repeated roots, so that when we find the value of y, if we write our value of y, this one now is, they have the same value, 2i, but take note, a plus bi. We have the value of 2i plus and minus. So for this case, you have here the value of a as 0, because we only arrived to positive, negative 2i. So take note, the value of a for this problem is equivalent to 0. And then also, these are repeated roots and imaginary roots. So that when we solve here, we have uh, c sub 1, okay, c sub 1, and then plus c sub 2, okay, x, and then cosine 2x. This is our 2x. Okay, we're supposed to have here e raised to ax, but our a is 0. So we cancel that e raised to. Okay, so sige. Okay, I will write it. Okay, e raised to 0x cosine of 2x plus c sub 3 plus c sub 4x, e raised to 0x, and then sine of 2x. Okay, so I will transfer this one. Now, if this is 0, so we will write now that is equivalent to 1, so that this is now c sub 1 plus c sub 2x times, we have here cosine 2x plus c sub 3 plus c sub 4x, e to the 0 is 1, and then we have here sine 2x. That is now our final answer. Take note, this is repeated roots and imaginary roots. So repeated, we have here c sub 1 plus c sub 2x. And then imaginary, we have here cosine sine.